Tonight I want to talk about supplementing wisely, and I'm going to cover 3 topics. The first is, should we supplement at all? And why or why not? We have to start there. The second is, we're going to talk about the basic principles of supplementation, and then the third is key supplements to consider taking and maybe a couple to be cautious with. Now, supplements is a very broad term, and we could spend, several evenings for 2 or 3 hours a night talking about supplements. So we have to narrow it down. And the purpose of tonight's talk is to focus on the basic essential nutrients that have been demonstrated to be beneficial for health, the ones that have the most research behind them and that our bodies absolutely need to function properly. Okay, so do we need to supplement? To frame this, I need to introduce a concept called nutrient density. Now, there are 2 types of nutrients. There are macronutrients, which are the basic building blocks of the diet, protein, fat, and carbohydrate. And then there are micronutrients, which are vitamins, minerals, and other compounds needed by the body in small amounts for metabolic function. Now, the term nutrient density refers to the concentration of micronutrients and amino acids, which are the basic building blocks of protein. The body needs about 40 micronutrients to function properly, and if we don't get enough of any of them, we are subject to an increase in the risk of morbidity or disease and mortality or early death. So in the industrialized world, our diets are calorie dense but nutrient poor. And the more calorie-dense, nutrient-poor food that we eat, the higher chance we will have of nutrient deficiency. So you could say that we are suffering from an epidemic of being well-fed, but actually undernourished. We think of nutrient deficiency as being something that happens in the developing world, but it's actually a very common problem in the developed world as well. A shockingly high percentage of Americans don't consume even the RDA for several different nutrients. So as you can see here, 98% of teens don't get enough vitamin D, 95% of adults, 99% of teens don't get enough vitamin E, 94% of adults. These are the ones that almost half of Americans are deficient in. But you can see here that 1 in 10 or more adults and teens also don't get enough B6, folate, zinc, iron, and thiamine, or B1. Now, this is alarming enough if you just take it at face value, but there are at least 4 reasons that nutrient deficiency rates on the last slide are significantly underestimated. Number 1 is that the RDA, the recommended dietary allowance, is only the amount of the nutrient required to avoid acute deficiency problems. It's not the amount of the nutrient that's needed to maintain optimal health over the long term or even to avoid chronic deficiency. Unfortunately, that amount is not even known for most nutrients because it hasn't been adequately studied, but it's almost certainly higher than the RDA. The second problem is that if we just measure the amount of nutrient that a food contains on paper without considering bioavailability, we're missing a really key piece of the puzzle. And bioavailability describes how much the nutrient is actually absorbed and assimilated when we eat it. And it's never 100% of how much of the nutrient is in a given food, and it's sometimes dramatically less. So calcium is a really good example of this. Calcium bioavailability from plant foods like dark leafy greens is affected by the presence of other compounds in those plant foods like oxalate and phytate. Oxalate and phytate actually inhibit the absorption of calcium from those foods. So if you see a nutritional information sheet and it tells you spinach has X amount of calcium, that doesn't mean you're going to absorb that amount of calcium from spinach because of the presence of oxalate and phytate. So one study found that while leafy greens like spinach and kale have a relatively high calcium content on paper, it would take 16 servings of raw spinach to get the same bioavailable calcium as you find in 8 ounces of milk. So that's a pretty big difference, and most people aren't even aware of this. They just assume that when they see the paper, they're getting that amount of calcium that's listed there on the paper. The third issue is that most nutrients require other nutrients to be assimilated and absorbed. So this is a concept known as nutrient synergy. An example is that copper is required for normal iron metabolism and red blood cell formation. And copper deficiency can actually cause a form of iron deficiency anemia that's not responsive to iron supplementation. So if that patient is copper deficient and they get tested for iron deficiency anemia and the physician gives them iron, they're not going to respond because the problem is actually copper deficiency affecting iron metabolism. The fourth issue is that chronic disease reduces nutrient absorption. So if we, again, just look at the amount of nutrient on paper and we're not considering things like a disrupted gut microbiome or dysbiosis or intestinal bacterial overgrowth or gastritis or other conditions that affect nutrient absorption, we're not getting the full story. So if you put all four of those factors together, the rates of nutrient deficiency are probably much higher in the US and industrialized population than those pretty shocking numbers suggested. Okay, so we've established that most Americans are deficient in several key nutrients and that these nutrients are critical for proper function. So what to do? Well, in an ideal world, we'd meet all of our nutrient needs from food, not supplements. Human beings are adapted to getting nutrients this way. Most nutrients require special enzymes and cofactors to be absorbed. I mentioned that before with nutrient synergy. And fortunately, nature has taken care of that for us. Generally, when we eat whole foods, the whole foods contain not only the nutrients, but also cofactors and enzymes that help us absorb those same nutrients. Getting nutrients from food is also safer than getting them from supplements. So for example, there's universal agreement that antioxidants in food are beneficial. This is because antioxidants are actually more accurately termed pro-oxidants. They are compounds that induce what's called a hormetic response, which is a response that causes a positive adaptation in the body. It's actually like a trigger that tells our body to upregulate its own endogenous detoxification response. And that works really well if it's a small dose of the nutrient. But when it's a much larger dose, as is present in a supplement, it actually can have the opposite effect. It causes oxidative stress or inflammation, and it doesn't have a positive impact on the body. But there are other concerns with supplements. Number one, it's much easier to get too much of a nutrient from supplements than food. For example, I've seen several patients in my clinical practice with iron overload or high iron levels because they were put on an iron supplement at one point, maybe 20 years ago, to correct anemia, and they never stopped taking it. And then the iron levels build up, and high iron levels are actually very problematic, just like low iron levels are. Number two, synthetic forms of nutrients and supplements may be different than the form of nutrient that's found in food. And folic acid is a good example of this. It's a synthetic form of natural folate, vitamin B9. And there are some studies that suggest that if you take large amounts of folic acid in supplements, certain groups of the population may not be able to process that well, and it's actually been associated with higher rates of cancer in some studies. This is somewhat controversial, but there are some mechanisms that could explain that. And number three, as many of you know, supplements are not well regulated or controlled, and many lack a solid evidence base. It's really kind of the Wild West when it comes to supplements, and you kind of have to know what you're doing. And it's not harmless necessarily. You can cause harm taking the wrong supplements or the wrong dosages for the wrong amount of time. So this is why I do think we should absolutely try to meet all of our nutrient needs through food as much as we can. It's certainly possible to do this with a whole foods diet, at least on paper. So this table here shows nutrient values of an average paleo type of diet. You can see you get about 800% of vitamin A in terms of retinol equivalents. You get almost 1,250% of vitamin C, so you're well above 100% for most nutrients. The one notable exception is calcium. And this is one reason I have never been an advocate of a strict paleo type of diet, or strict any kind of diet for that matter, unless you really need to be. Dairy products, even though they're much maligned in the sort of alternative health community, many studies show that they can be beneficial if they're well tolerated by the individual, and this is one reason. It's a very good source of bioavailable calcium. Unfortunately, we don't live in a perfect world. Even with an optimal diet, it can be hard to meet our nutrient needs in all cases. And there are several reasons for this, including nutrient depletion in soils. Over the past several decades, there's been a decline in the level of certain nutrients in soils. Therefore, the foods that we're eating that are grown in those soils don't have the same levels of nutrients that they did for maybe our parents or grandparents. There have been changes to our gut microbiome due to antibiotic use and poor diet and a number of other factors. And our gut microbiome affects how much of nutrients we extract from food. There's been an increase in the prevalence of many chronic diseases, like Dr. Heck mentioned, an 8-fold increase in diabetes in the last several decades. Many of these chronic diseases do affect nutrient absorption, or at least demand. There's been an increase in exposure to environmental toxins, which can interfere with nutrient absorption. And then there's been an increase in the prevalence of food allergies, which lead to a more restricted diet and a lower nutrient intake. So this is why I do think that most people may need some ongoing supplementation with at least some nutrients. But the question, of course, is which ones? This is unfortunately a very difficult question to answer in a general sense, because the answer depends on so many different factors. An individual's diet, their gut health, their genetics, their gene expression or epigenetics, their health status, geography, season, etc. For example, somebody who lives in Boston in the winter is going to be much more likely to need vitamin D than someone who lives in Rio de Janeiro in the summertime. Someone that has a polymorphism in MTHFR genes, which affect folate metabolism, might be much more likely to need ongoing folate supplementation than someone who doesn't have those polymorphisms. Someone on a vegan diet may need to supplement with B12 and DHA and maybe with other nutrients, whereas someone on an omnivorous diet may be less likely to need to supplement with those nutrients. I think it's also helpful to have a framework for talking about different types of supplementation. So I break it into two categories: therapeutic supplementation and maintenance supplementation. With therapeutic supplementation, we're taking supplements for a specific period of time for a specific purpose. So an example would be taking iron to correct iron deficiency anemia. Once that's corrected, we can then hopefully get enough iron from our diet and move on and no longer take the supplement. With maintenance supplementation, we're augmenting nutrients from the diet that we can't get enough of from the diet to meet our long-term health needs. And an example there would be taking vitamin D if we can't meet our needs through diet and ultraviolet light or sun exposure. So my approach is to use therapeutic supplements, preferably under the guidance of a healthcare practitioner, as indicated by testing that shows that you have a need for that. For example, you go to the doctor and you find out you have anemia and you take the iron supplements. Then consume a nutrient-dense whole foods diet to try to meet as many of your ongoing nutrient needs from food as possible, so that you can take only what nutrients that can't be fully or reliably obtained through the diet. So we're starting with food as much as possible and then narrowing it down and only taking what we can't reliably obtain in the form of supplements. So therapeutic supplementation is beyond the scope of this evening's talk. And we don't have time to talk about all possible maintenance scenarios for every different type of person. So I'm going to talk about maintenance supplements to consider when you're already on a relatively nutrient-dense diet. So let's just make the assumption that everybody here is on a nutrient-dense diet, and then we'll build from there. So let's start with vitamin A. This is critical for vision. It's a component of rhodopsin, which is a protein that absorbs light in the retina. It's required for the assimilation of protein, minerals, and water-soluble vitamins. It supports cell growth and differentiation. It acts as an antioxidant, and it plays a really crucial role in reproductive health, particularly in the development of the facial structure for the developing baby. There's something that's really important to understand about vitamin A that's not well known, at least in the general public. There are two forms of vitamin A. There is active or preformed vitamin A, which is retinol or retinol esters, and then there are vitamin A precursors like beta-carotene or carotenoids. So these are found in carrots and bell peppers, the brightly colored foods, whereas the retinol and the retinol esters are almost exclusively found in animal products like liver and egg yolks. Now, here's the key thing to understand. The vitamin A precursors, beta-carotene and carotenoids, can be converted in our body to the active forms of vitamin A. But that conversion is somewhat limited, and for some people, they don't do it very well at all. Has anyone ever done like carrot juicing cleanse or fast and their hands, the palms turn orange, or has seen somebody that did that? That's probably someone who doesn't make that conversion very well, and so they get a buildup of the carotenes that actually affects their skin pigmentation. Unfortunately, food labels don't really differentiate between vitamin A precursors and active vitamin A. Some supplement labels do. So you'll see 20% as beta-carotene, then you assume that 80% is the active form. But many food labels don't. They just list all vitamin A together. So that means it's possible for someone to be eating plenty of total vitamin A, including the precursors, but still be deficient in the active forms of vitamin A, retinol or retinol esters. To get adequate amounts of retinol or retinol esters from the diet, one option is to consume 3 to 6 ounces of liver, beef liver, chicken liver a week. Organ meats have definitely fallen out of favor over the past few years. How many people eat organ meats in this room? Okay, that's probably more than the average group. You know, many of our grandparents did. But they actually, pound for pound, if you look at essential nutrients, they're one of the most nutrient-dense foods on the planet. And if you look at the eating patterns of traditional hunter-gatherer groups around the world, almost universally they consume organ meats. Egg yolks, particularly pasture-raised eggs from chickens that have been eating green grass, tend to have pretty high amounts of preformed vitamin A as well. If supplementation is necessary, one way of getting preformed vitamin A is cod liver oil. So it's oil from the livers of codfish. And this isn't so much of a supplement in terms of being a synthetic nutrient as it is a superfood or a food supplement that you would add to your diet. 1 teaspoon contains about 4,000 IU of retinol, which is right in line with what the RDA is for retinol or retinol equivalents. Okay, vitamin D is next. Vitamin D is actually often referred to as a vitamin-like hormone. It has some characteristics of a vitamin, some of a hormone. It's largely produced internally when our skin is exposed to ultraviolet light, sunlight, for most of us. Its best known role is increasing intestinal absorption of calcium. So vitamin D plays a very important role in calcium metabolism. It also enables mineralization of bone and has a number of other benefits, particularly with the immune system, metabolic health, cardiovascular health, and the endocrine system, or hormones. We saw on that table a few slides back that most people are deficient in vitamin D. They don't get enough, so most of us need to consider additional sources. There are 3 sources of vitamin D: food, sunlight or ultraviolet light exposure, and supplements. Food only contributes about 10% of total vitamin D requirements for most people with an average diet. So it's not a sufficient source of vitamin D for many people, which is why so many are deficient. And sunlight is not really a viable route of exposure for most people now because of our indoor lifestyle. You know, we live in the Bay Area in the wintertime, you know, the solar angle is low, so even if we are exposed to sun, we may not produce very much vitamin D. So vitamin D is one of those nutrients that many people actually probably do benefit from supplementing with, although even that is somewhat controversial. Cod liver oil also contains vitamin D in addition to vitamin A. 1 teaspoon contains 400 IU, which is 100% of the RDA for vitamin D. Also, vitamin A and D have a synergistic relationship. Vitamin A protects against toxicity of vitamin D and vice versa. So this is, again, is another nice nutrient synergy thing that's happening in a whole food. And cod liver oil kills 3 birds with 1 stone. It doesn't just have vitamin A and vitamin D, it also contains EPA and DHA, which are the long-chain omega-3 fats, which are anti-inflammatory, and which many Americans also don't get enough of. Sun exposure, ultraviolet light exposure is the best option if it's feasible. Full body exposure to midday summer sun will produce about 10,000 IU of vitamin D in half the amount of time it takes your skin to turn pink. And I put it specifically that way because everyone has different skin tones. So someone with darker skin will have to spend more time in the sun to produce that amount of vitamin D, whereas someone with very pale skin, that could happen in as little as 10 to 15 minutes in the summer when the solar angle is high, or if you're living in a more equatorial region. However, both obesity and inflammation have been shown to decrease the conversion of sunlight into vitamin D. So you could take 10 different people, and they would produce, even with the same skin tone, and they would produce different levels of vitamin D given a certain amount of exposure to sunlight based on what's happening in their body. So there are a lot of factors to consider. So D3 supplementation is often required for the reasons that I just mentioned. The target I would suggest is between 40 to 60 nanograms per milliliter. You see some recommendations to drive vitamin D very high, up to 100. I don't believe those are justified or warranted, and I think there's some concern about toxicity at that level. The Institute of Medicine recommends a range of 25 to 50. I think 40 to 60 is a nice, safe middle range that is not very controversial in the scientific literature. It is important to get your vitamin D levels tested. I have seen many patients in the clinic who have toxic levels of vitamin D because they went to the doctor, again, several years ago. They got tested. They were really low. The doctor put them on 10,000 IU a day, a very high dose, and they continued to take that dose for several years, and then they come in and they get tested and their level's 120 or 130. Levels of vitamin D that high have been associated with kidney stones and arterial calcification, more deposition of calcium in the arteries, which increases the risk of heart disease, which is the #1 cause of death. So we're not doing any favors by taking very high amounts of vitamin D for a long period of time, and it really is important to get your levels tested. Your doctor will do it. You can order even at-home tests. It's very easy to do, so just make sure that you do that if you are going to supplement with vitamin D. The next nutrient is magnesium. It's absolutely vital to the body. It's used by over 300 enzymes, including every enzyme that's involved with ATP, which is the fundamental energy currency in the body. And it's used by enzymes that are involved in DNA and RNA production. It also plays an important role in bone health. And in fact, most of the magnesium in our bodies is stored in our bones, over 60% of it. Magnesium helps transport ions across cell membrane surfaces, so it's very important for cellular communication. Magnesium deficiency is associated with a wide range of syndromes and diseases, including diabetes and hypertension, cardiovascular disease, migraines, PMS, asthma, and hypothyroidism. And as the study here on the slide suggests, even subclinical magnesium deficiency has been shown to increase the risk of cardiovascular disease. So that means low normal magnesium levels. Magnesium levels are still in the normal range, but on the low end of that range. Again, according to the table that we saw a few slides back, which I forgot to mention, is from the Nurses' Health Study, the NHANES study, suggests that most Americans are deficient in magnesium. The median intake is well below the RDA of 400 to 420 milligrams for adult men and 310 to 320 milligrams per day for adult women. It can be difficult to get enough magnesium in the diet for a few reasons. Number one, soil depletion of magnesium has been pretty significant over the past few decades. And then anti-nutrients like phytic acid, and oxalate or oxalic acid also can interfere with the absorption of magnesium from certain foods. So the optimal intake range per day, I think, is probably somewhere in the range of 500 to 700 milligrams per day. The food sources of magnesium include the leafy greens, nuts and seeds like pumpkin seeds and almonds, bananas, and chocolate. Yay! So there's some good news, right? But remember, the phytates in these foods will reduce somewhat the absorption of magnesium from these foods. And it's really interesting. When you look at traditional cultures and their diets, somehow they knew this. They didn't have the data, the science, but most traditional cultures soak the nuts and seeds before they consume them. They soak grains before they consume them. They soak legumes before they consume them. And now what we understand is that soaking actually activates enzymes which break down phytic acid and oxalic acid, and then that improves the bioavailability of the nutrients in these foods. So soaking and then dehydrating or sprouting or even roasting nuts before you consume them, or just choosing roasted nuts, actually can be better than raw nuts for this reason. You can absorb more nutrients from them. Having said all that, because of the challenges with magnesium, it is one nutrient that quite a few people will benefit from supplementing with. The average American right now gets less than 250 milligrams per day of magnesium, which is, again, below the RDA for both women and men. So supplementing with between 100 to 300 or 400 milligrams per day of magnesium can be beneficial depending on your background intake from diet. And I prefer the glycinate and malate forms, which are the chelated forms of magnesium. Some studies suggest they're better absorbed, and they tend to produce fewer bowel-related symptoms for patients. Magnesium oxide or citrate can sometimes cause diarrhea or loose stools, whereas the malate and glycinate don't tend to do that. Vitamin K2. How many people have heard of vitamin K2 in here? Okay, so it might be the most important nutrient that many people haven't heard of. It was actually only fairly recently discovered as a different type of vitamin K. Vitamin K1 is found in leafy greens and plants. Vitamin K2 is different. It regulates calcium metabolism, so like vitamin D. Vitamin K2 basically tells your body where to put calcium. It tells it to put it in the bones and the teeth where it belongs and keep it out of the soft tissues like your arteries where it doesn't belong. So it plays a very important role. And given that, it's not surprising to see there's a study out of the Netherlands found, they looked at people, this was an observational study. They looked at people and separated them into quintiles, 5 different groups based on their vitamin K2 intake. And the people that were in the highest group of K2 intake had 52% lower risk of aortic calcification, 41% lower risk of coronary heart disease, 51% lower risk of death from heart disease, 26% lower risk of death from all causes. Now, as Dr. Hecht explained, there are lots of different problems with observational studies and drawing conclusions from them, but when you understand the mechanism and what vitamin D does, this does make some sense. And there have been some RCTs with vitamin D, or vitamin K2, out of Japan using it for osteoporosis prevention and treatment at higher doses that are really interesting. K2, again, is different from K1. K1 is found primarily in plant foods. Some K1 can be converted into K2, just as beta-carotene can be converted into active vitamin A, but again, that conversion tends to be limited in humans. Ruminant animals are very efficient in doing that conversion. And so K2 is found in the diet in higher amounts in animal fats because they eat grass, they convert that K1 into K2 very well, and then that K2 ends up in their animal fat. So the 2 different forms of vitamin K2 are menaquinone 4 or MK4 and menaquinone 7 or MK7. MK4 sources are primarily animal foods, so grass-fed, full-fat dairy products like butter, cheese, and cream. Certain cheeses are very high in K2, like Gouda and Brie. Then you have, chicken liver, goose liver, poultry liver, and pastured egg yolks are high sources of K2. But K2 is also in fermented foods in the MK7 form. So This is natto, which is a fermented soy product. Anybody a natto fan in here? Yeah, not a fan, she said. People are either fans or not fans. There are nobody I know is neutral on natto. But it is by far the highest source of K2 in the diet, hands down. But other foods like sauerkraut and kimchi, and of course cheese, which has the animal fat and fermentation, that's why some of the cheeses are the highest sources of K2. So for supplementation for K2, I will, if people aren't getting enough in the diet, and especially if they're at risk for osteoporosis or cardiovascular disease, or they've had a high calcium score, or they've got some kidney stones, calcium oxalate kidney stones, or other evidence of calcium deposition in the soft tissues, or they've got a deterioration of poor dental health, K2 supplementation could make sense. The recommended maintenance dose is between 100 and 1,000 micrograms per day. Doses of up to 45 milligrams per day, not micrograms, but milligrams, have been used in the Japanese osteoporosis studies with no adverse effects. There's currently no known upper limit of K2. So unlike vitamin D and vitamin A and most other nutrients that can be toxic at high doses, at least as far as we know, vitamin K2 is not one of those nutrients that has an upper limit. Iodine is required to make thyroid hormones, both T4 and T3. The thyroid gland of healthy adults contains about 70 to 80% of the total body iodine. And iodine deficiency globally is a pretty big problem. It's less of a problem now in countries where salt has been iodized, like the United States. But globally, it's a significant cause of brain damage, impaired mental and cognitive function, goiter, and other growth and developmental issues. Now, the strange thing about iodine is that people who are following a healthy diet are maybe more likely to be deficient in iodine. Why is that? Because the main sources of iodine in our diet are fortified foods, iodized salt, and dairy products. And a lot of times when people switch to a healthy diet, they switch to sea salt, they stop eating bread and fortified food, and they stop eating dairy products. So they've just removed all of the main sources of iodine from the diet. And there was a reason that salt was iodized in the first place, because there weren't many sources of iodine in the American diet. Here we go. So fish are not typically a good source of iodine. The exception is cod. Shrimp is also a decent source. But Japanese people are not iodine deficient generally. And this is one reason. They consume a lot of sea vegetables. And sea vegetables, as you can see here, kelp is just killing it in terms of iodine content. It's not even close. 1 gram of kelp flakes a week, which is not much, can meet your iodine needs for the entire week. So you get some kelp flakes, you measure out 1 gram, put it in a little jar. When you're going to reach for some salt, reach for the kelp flakes, sprinkle them on scrambled eggs, put them in soups, whatever, and you're done. You've taken care of your iodine needs. Other sources, as you can see, dairy products are a good source of iodine for 2 reasons. They're in the dairy themselves, and this might sound weird, but the tanks that store dairy products are iodine-based. Iodine is used as a cleanser for the tank, and it gets into the milk. So that's another reason that dairy can be a good source of iodine. Okay, next is calcium. Important element of bone and teeth, also plays a role in cell signaling. Levels of calcium in the blood are very tightly regulated by parathyroid hormone and vitamin D. This is a problem because we can't accurately assess calcium levels by measuring it in the serum because it's so tightly regulated by those other vitamins and hormones. If your calcium intake in the diet is not high enough, calcium is so important, serum calcium level, your body will take it out of your bones to maintain adequate serum levels. And that's why calcium deficiency causes osteopenia and osteoporosis. Now, the RDA for calcium is 1,000 to 1,200 milligrams a day. And we saw on the previous slides that even a nutrient-dense diet may not have enough calcium. 80% of adolescents and 50% of adults don't get enough in their diet. But supplementation with calcium is quite problematic. This become popular, especially with middle-aged and elderly folks as we get older, to prevent osteoporosis. Given calcium's role in bone health, that's understandable. But calcium supplements have been very disappointing in studies. They have not only not been shown to reduce fracture rates, they actually increase them in many studies. Supplemental calcium is also associated with a higher risk of cardiovascular disease. In a 2016 study in Journal of American Heart Association, people with a high intake of dietary calcium had a lower risk of arterial calcification and cardiovascular disease. However, the opposite effect was observed for people with a high intake of supplemental calcium. So this goes back to what the slide Dr. Heck showed, where people with higher levels of dietary C may have been at lower risk, but people then who took vitamin C and other supplements were at higher risk. Supplemental calcium does not have the same impact on the body as dietary calcium. And the thinking is that it's such a large bolus of calcium all at once that it affects the serum level of calcium in a way that dietary calcium does not. Just a few more statistics here. A study of 24,000 men and women between the ages of 34 and 65, published in BMJ in 2012, showed that those who supplemented with calcium had almost 140% higher risk of heart attack than those who got calcium from food. A meta-analysis in BMJ, 12,000 participants, showed that those taking supplemental calcium had a 31% higher risk of heart attack, 20% higher risk of stroke, and 9% higher risk of death from all causes. And another analysis in JAMA Internal Medicine, also with 12,000 participants, found that intake of over 1,000 milligrams per day of supplemental calcium increased the risk of death from cardiovascular disease by 20%. I'm sorry, I might be dropping pretty big bombshell right here. I'm sorry we don't have more time to talk about this, but I felt like it's really important for you to know. So I recommend that calcium come from food as much as possible. Sesame seeds top the list, but remember what I said before. Seeds have phytate and oxalic acid sometimes, and that's going to impair the absorption of calcium. So even though, and same with greens. So collard greens is listed above canned salmon with bones, but you're probably going to absorb as much or maybe even more calcium from this than you would from collard greens. That does not mean you shouldn't eat greens and you don't get calcium from greens. You do. But it does mean that if you're exclusively eating these foods, you might not be getting as much calcium as you think you're getting. If bone health is a concern and that's why you're using calcium, you also I recommend, as I said, to get calcium from diet, but you also need to pay attention to vitamin D and K2. As we've discussed, they play a really important role in bone health. K2 makes sure that calcium gets into the bones and stays out of the soft tissues, and vitamin D makes sure that calcium gets absorbed from your gut. So in many cases, it's a better strategy to focus more on K2 and vitamin D, and in addition to getting your calcium from the diet, than it is to take calcium supplements. Weight-bearing exercise, also crucial for bone health as we get older. Okay, last one is vitamin E. It's potent fat-soluble vitamin, anti-inflammatory, protects us from free radicals and oxidative stress. Recall from the table before that 94% of adults and 99% of teens don't meet their dietary requirement for vitamin E. So everyone should take vitamin E supplements, right? No, that's right. So while vitamin E is important to get in your diet, I don't recommend supplementing with it. At best, alpha tocopherol, which is the most common isomer of vitamin D, shows no benefit in studies. In many studies, like Dr. Heck showed, it had no benefit or there was an increase in the risk of heart disease. Meta-analysis in JAMA with 230,000 total participants showed that vitamin E supplementation caused increased risk of death from all causes. A review of 78 RCTs, randomized controlled trials with almost 300,000 total participants, found that vitamin E increased mortality by a small but a statistically significant margin. So as with calcium, it's best to aim for whole food sources only, in my opinion. The RDA is 15 milligrams a day. Most people get whatever vitamin E they do get from highly processed industrial seed oils like soybean oil and cottonseed oil that are in processed food. I would submit that better sources include spinach, turnip greens, chard, sunflower seeds, almonds, bell peppers, asparagus, collards, kale, broccoli, and Brussels sprouts. It's very important to eat vitamin E and all fat-soluble vitamins, A, D, K2, with some fat. That's why they call them fat-soluble vitamins. They actually need fat to be absorbed properly. And there have been some interesting studies, which I don't have time to go into, that looked at people consuming salads with no salad dressing, just plain lettuce, and then people consuming salads with dressing, and the amount of nutrients they absorbed from the salad with the dressing, which of course contained fat, is much, much higher. So there are many other nutrients that we could talk about if we had time. EPA and DHA for people who are not eating much seafood. Folate for people maybe with MTHFR polymorphisms. Iron for women with heavy menstruation, perhaps. Nutrients for people who are on a vegetarian or vegan diet. We need to finish up, but I want to leave you with 3 key takeaways. So number 1, food is the best medicine. Food is the best medicine. So our primary goal should always be to get as many nutrients from food as possible. In the case of nutrients we've discussed, even if you're not getting enough through normal diet, you can first try adding certain foods to your diet that you might not otherwise eat, like liver. I saw a lot of frowns when I started talking about liver. Cod liver oil, sea vegetables like kelp flakes, and dairy products if you tolerate them in order to meet nutrient needs. So you could consider those as supplemental foods, if you will, or superfoods. And then the other issue is that in some cases, like with calcium and vitamin E, it's risky to use supplements at all. So you pretty much have to meet those needs through diet. So supplements should be a last resort, not a first option. The second takeaway is that you cannot supplement yourself out of a bad diet, okay? You don't get to just eat donuts and take a multivitamin. It does not work like that. If you do that, you're not going to last very long. We won't see you back next year, and that will be unfortunate. So, eating a really calorie-dense, nutrient-poor diet with lots of processed and refined food and then going home and taking a cupboard full of supplements is just not a good approach. It's like building a house on a really shaky foundation in a swamp. It might stand up for a little while, and then it's just going to all fall apart. Number 3, if and when you do supplement wisely. So for maintenance supplementation, as we've discussed, that means focusing on essential vitamins and minerals like A, D, K2, magnesium, and iodine. And then exercising caution with nutrients like calcium and vitamin E. And then taking a conservative approach to antioxidants and so-called anti-aging products and all the fancy woohoo supplements that we haven't had a chance to talk about tonight, and for a reason. The best way to slow aging and optimize health is to focus on the basics: diet, lifestyle, and behavior change. So a nutrient-dense, anti-inflammatory, whole foods diet, getting 7 to 8 hours of sleep per night, getting adequate physical activity, which I believe you talked about last week, spending time outdoors in nature preferably, having more fun, improving our social connections. These are the things that are just part of our basic operating system as human beings, and they're where you're going to get the biggest bang for your buck. It would be far better for all of us to focus our energy on these things than fancy supplements. We'll live longer, we'll be happier, and we'll save a lot of money. Thanks for listening. Almond milk would contain supplemental calcium because almonds don't contain calcium. So it would be a fortified food with supplemental calcium, and I would have the same concerns. Oh, sorry. What do I think of almond milk as a source of calcium? That was the question. I wish they sold almond milks that weren't fortified with various nutrients, because it's hard to find ones that don't. You end up having to make it yourself, which is fun the first time or the second time. And then once the novelty wears off, then it's just not that fun anymore. Yes? Fish oil, wow, that's a whole nother lecture for sure. I think the best way to get your EPA and DHA is from eating fish and seafood. And I know that's problematic, and that leads to a whole nother discussion about overfishing and mercury and toxic metals. Whew, it's so confusing, isn't it? So confusing. I really feel for everybody in this room, including me. But yeah, eating fish is the best way to meet those needs. Fish oil was really hot for a while. Now it's kind of cold. The last few studies that have come out, even on fish oil and cardiovascular prevention, have been not very exciting and actually showing a trend in the opposite direction in some cases. And for certain conditions, it doesn't seem to be, and others it does seem to be. That's why I'm sorry. It's just so hard to give a clear answer about it. And that's, again, why over and over again I come back to food, because it's the safest way for us to meet our nutrient needs. There's so many unanswered questions when it comes to supplementation. So I just throw my hands up and I go, well, we've been eating fish for a really long time. Really long time. So I think we can continue to do that. Yes?
Is cod liver oil considered fish oil?
Is cod liver oil considered fish oil? It's a good question. So cod liver oil has pretty low levels of EPA and DHA relative to other fish oils. It's mostly a vitamin A and D source. It's got active vitamin A, retinol esters, and it's got vitamin D. It does contain some EPA and DHA, but not at like the high levels that isolated extracted fish oil contains. In the back.
What about multivitamins?
Multivitamins, great question. I had that in there, but it was too much and I cut it out. But so multivitamin studies have also been disappointing, and some have actually indicated a trend towards increased risk. I really am much more of a believer in selective supplementation. So that's why I structured the presentation this way, trying to figure out the nutrients that you're not getting enough of in the diet and only taking those if necessary. Examine.com, does anyone know that website? They do some really good reviews of research literature. They have a large a board of scientists that are pretty rigorous, and they just published a review of multivitamins, and the gist was basically the last 3 points in my presentation, which was supplements are, multivitamins should only really be considered by people who for some reason, due to a health condition or poverty, cannot meet their nutrient needs through food. Otherwise, if you're eating a healthy, nutrient-dense diet, you should not be taking a multivitamin. Anything I can say about supplements or deficiencies related to arthritis? In a couple minutes. I think with conditions like that, at least for the purposes of this discussion, just making sure you're getting all of the nutrients that regulate, have an impact on bone health, and also the ligaments and connective tissue, which are the ones that we talked about. And maybe if we have time after, and you're going to stick around, I'll stick around for a few minutes and talk a little more about that.
We'll take one more question.
One more question. Yes? Probiotics. So you might not be surprised to hear me say this, but we can actually meet our need for beneficial bacteria by eating fermented foods. And that's the way our ancestors did it before refrigeration. Fermentation was the only game in town when it came to preserving certain foods. So sauerkraut, kimchi, beet kvass, yogurt, kefir, if you tolerate these kinds of foods, kombucha, water kefir. I mean, you walk into Whole Foods now and there's like whole aisles full of these kinds of fermented foods that I'm sure a lot of you are like, what the heck is that? I've never even seen or heard of that. But they're really beneficial. And most traditional cultures, again, have consumed fermented foods. And now with the research coming out on the importance of the microbiome, not only to our gut health, but to all of our health, I think that's a really good insurance policy. Okay, thanks so much for your attention.